In this video, we are going to continue finding derivatives of functions using implicit differentiation. So we will look at two examples in this video. So let's jump into our first example. We have x plus 3 over y equals 4x plus y squared. So we're going to take the derivative of the left-hand side first. When we take the derivative of this, we have x plus 3 divided by y. So when we take our derivative here, we need to use our quotient rule, or you could rewrite that and use a product rule if you wanted, along with a chain rule a couple times. But let's go ahead and use a quotient rule here. So our quotient rule, we take the derivative of the bottom, not the derivative. We take the bottom, the low, d high. What's the derivative of the top? Well, the top is x plus 3, so the derivative of that is 1. Minus high, d low, the derivative of the bottom is y, so its derivative is just dy dx. So low d high minus high d low, square the bottom, and away we go. So that's our left-hand side derivative. On the right-hand side, we have the derivative of 4x is 4. The derivative of y squared is 2y. And again, we need to pick up a dy dx. So now we have two different dy dx's floating around. So our goal here is we're going to try to get all of the stuff that has dy dx. We're going to try to get that together on one side, and anything that does not have that, we will try to get together on the other. So first, I'm going to multiply both sides by y squared to get rid of that fraction, to get rid of this denominator on the left. So we have y minus x plus 3 dy dx equals 4y squared plus 2y cubed dy dx. Now I'm going to move anything that has dy dx to one side, anything that does not have dy dx, I'm going to move to the other. Because I like to avoid lots of negatives, I'm going to add this to both sides and then subtract this. That way my coefficient of dy dx is all positive. If you moved it to the left-hand side by subtracting this and subtracting this to the other, that would also be fine. So it's your preference, but I'm going to move the dy dx to the right-hand side in this case. So we're going to have 4 minus 4y squared is equal to 2y cubed dy dx plus x plus 3 dy dx. All right, so we added this to both sides, and we subtracted this from both sides. Now everything that has dy dx is over here on the right-hand side, and on the left-hand side is only things that do not involve that dy dx. So we're trying to solve for dy dx, and so our next step is on that right-hand side, we're going to factor out a dy dx. And if we factor out that dy dx, we have 2y cubed plus x plus 3 times dy dx. And finally, to get dy dx all by itself, we are going to divide by that. So dy dx is equal to y minus 4y squared over 2y cubed plus x plus 3. That is our derivative, which we found implicitly. All right, let's look at one other example, and then we will close this video. All right, so now let's look at the sine of xy is equal to x squared minus 3. So we're going to take our derivative. When we take the derivative of this left-hand side, we have a chain rule showing up right away. So our outside function is sine. The derivative of sine is cosine. The inside stays the same. Then we need to multiply by the derivative of the inside. What is the inside? The inside is x times y. So when we take the derivative of that inside, we have a chain rule, that's a product rule that's happening. Not a chain rule, a product rule that's happening. The derivative of the first, the derivative of x is 1, times the second, plus the first, times the derivative of the second. The derivative of y is dy dx. And on the right-hand side, we have 2x minus 0, or just 2x for our derivative. So on the left-hand side, we have y cosine of xy plus x cosine of xy dy dx. Our goal is to get dy dx all by itself. So let's move the y cosine xy to the other side by subtracting it. So we have x cosine xy dy dx is equal to 2x minus y cosine xy, and then divide by the x cosine xy. To get this. And that's our derivative. We found it implicitly. We still have x's and y's floating around in our derivative on the right-hand side. If we wanted to know what is the derivative at a point, which we will find in one of our upcoming videos, then if I wanted to know what's the derivative when x is, let's say, when y is 0 and x is the square root of 3, well, then we would just plug in 0 and the square root of 3 for x and y. So if y is 0, we'd plug in 0 for y. And if x is square root of 3, we'd plug in square root of 3 for x. And then we would get an answer. We could find the derivative at that point. But we'll look at examples that involve that. And so we will see you next time.